Good evening, my viewers, and thank you, Sohini, for the preparation of the audio-visual setup and the entire arrangement for this lecture to be delivered. This evening, what actually we will discuss, of course, this is demo session 4, remember, and in demo session 3 we covered this one, so I'm erasing which are not required, the parts which are not required, but some leftover parts, and with the help of the diagram already sort of drawn on the board, so I may sort of take some help of that and refer time to time that while discussing this, various kind of lecture components or so. Now this IS codes already discussed, so I am erasing this. It is no longer required for this. I think you have noted also down this. So IS code part, this is I am erasing. Okay. Now the leftover parts of the water supply, the scheme also. Here I have explained this, that the overall this flow diagram of the water supply schemes, starting from collection through treatment and ultimately the supply to the distribution system. Now we will discuss this in more details later, right? In our sort of subsequent videos to be uploaded or to be rather, to be shared with the registered participants and the students also. Now here I just would like to mention here what we discussed this, in the demonstration 3 or so. That was, that the distribution system which actually are of closed distribution, closed in the sense closed network. There is a loop system. Okay, this is a loop system, and the design part I am not here discussing, because that for that actually the dedicated videos will be there for the design of that. But just to say, make you understand that this is the pipe network in loop kind of this, because all are connected as you see here, closed loops. So, but it may be, that kind of dead iron system also. While this is the complex, this pipe distribution network, which are interconnected also. But in case of, this dead end system, there is another system also, which is quite old, and in many sort of, places, particularly the peri-urban areas or so, small towns also, this system also is followed, where actually this is, you see that here I am giving diagram which is available in SK Garg. You can follow this diagram, and here as you see that I will just little bit elaborate, that. So for that actually the pressure requirement, as I have mentioned, that the residual head, this is also called the residual head. If I have missed in the earlier previous video session, so I am just here taking an opportunity to tell that these are all residual heads, right? So the residual heads means here at the furthest end this must be maintained, so that the water supply, the pressure, that will be adequate, so that the consumers, at consumers point also, sufficient pressure is there, and the supply is smooth and adequate to the consumer. Now here let me erase this part also, right? I'll come back here, so that's why I'm not rubbing it out. Now this actually, as you see that, suppose this is the overhead tank or so, this is plan, right? Now this may be connected this way, let's say another this side, and here different parts may be there. Say here the population maybe say 500, say, then this is 300, this is say 1000, right, like that. Similarly here, I'm not wasting time on this. The basic objective of this actually network for explanation, which I want to explain also. So this is, I mean, feeling hot, little hot. So you can just, I mean, go ahead. Oh, this is okay. Anyway, so this is a, you know, the overhead tank or reservoir. What you see here on plan, it looks like this. It looks like this. So this is supplying this way, right? Population, and this network or I mean dead end system also. A dead end system means here you see that these all the pipes are not connected, right? So this is like that. So when you will design supply this one here, you have to sort of decide that what is the head here to be maintained, and what is that supply, what is the pipeline diameter also. This would be decided, okay, based on the head available and the requirement of the total this quantity of water. Similarly, as it, you know, proceeds away from the overhead tank also, then, you know, the head will be diminishing, right? So that is to be sort of kept in mind, that that head actually, again the same thing, that is residual head for different kinds of buildings also, stories of building also, that must be maintained. So this is the design. I am not talking about the details of design of this system, but this is a, you know, candidate system, or I mean another this option to this one alternative also. But normally for urban areas also, as I have shown, that one, you know that the network closed loop system that is followed, while for the mid-level town or peri-urban or semi-urban area also, this dead end system there. So one system, the supply or distribution system, right? The major types I'm giving here, distribution system. So this is, one is that, you know, that is the closed loop or the complex network, that is the which is operated or which runs in a closed loop manner. And second one is the, you know, the dead end system. Dead end means here the dead end means as it is going, it is not connected also. So it may not be connected, may be connected also, but this actually this is the farthest end so far as this area is concerned also, right? Similarly, if there is another area, suppose here, so this will be supplied from here, right? And that would be the farthest end would be here. So no connection among the pipelines also. So that is the dead end system. And also, as I have already discussed, that we have got this type of system depending or based on the pipe network and the laying of pipes also. And another way to classify this, that is actually the distribution system also. That is, as I have already discussed, that is another way is that this is the continuous supply system. And another is the intermittent supply. That already has been discussed earlier. Okay, so I'm not repeating this one. Okay, so let me erase this one. I think you have taken a note of this. And one thing to say that regarding this demo, this series, if you have got sort of any question that registered this participants, so they actually, I mean, will get an opportunity to interact on virtual or online this, meet, as we already have spoken about. That is the, Google Meet also, we can, there also we can discuss. So this, I'm leaving for, interaction part. I'm leaving to this, the registered participants, when we will, meet virtually also, right? So here there is no scope to interact with the participants or the students also. Now the distribution, that system, what I have discussed already, with reference to water supply system. Remember, I have already, I think, told. I don't remember whether I have told, but let me repeat it once again. That is, water supply, that system, the difference, major difference between the two systems, that is the sewer line, the sewerage system, and the water supply network, is that for water supply, remember that usually that is the, pressure flow, right? That means when the pressure flow means the pipe running full of water and it is under pressure. Because as we have already told, the farthest end, actually there we have to ensure that for different story the buildings, different the heads to be maintained. So when this heads to be maintained, this actually requires to be under pressure also, right? So this is the pressure flow, which is that running pipe, you can say the pipe running full. That means this is the pipe, say, in the longitudinal section, if we see the pipe fully, this pipe actually running full. This is the water level, actually this in the surface, this one. Whereas for the sewage flow, right, sewage or wastewater flow, say, that is that sewer line, through sewer line in the sewerage system, all explained earlier. So this is a gravity flow, right? Because here actually in pressure flow, remember that in water supply system, immediately below or downstream of that, this is actually with larger pressure, greater pressure. As it is proceeding also, the pressure is reducing also, right? Because it is distributing. It keeps distributing the flow also, and naturally the water, this discharge or flow, will be diminishing as it proceeds away from the reservoir also to the farther and farthest end of the network, pipe network. But in the sewerage system, remember, that is the collection also. That means it is just reverse. It is collecting the sewage, domestic sewage also, from different buildings also. Then it is, going to the submains, through laterals, submains, or the mains, then intercepting sewer also, that we already have explained. So here I am not repeating this. So this actually here different. This is a collection. That means here it is collecting, then it is going like that. Here also it is collecting, say, on this one. Here there is sewer, so it is discharging here, so it is going like that, and another area like that. So it keeps collecting from the farthest end, and it is, as it is going to the treatment plant also, the wastewater flow is increasing, right, as it goes to the treatment plant also. And this actually remember that these are buildings also, so maybe institutional buildings, commercial buildings also are included here, and some industries may not take the water from the municipal water supply system also, because their water source may be different. Suppose the groundwater source they are using, because of the quality requirements, right? The water quality requirements in this connection, let me have this opportunity to, or privilege to show you that I have got some codes, different codes are there where you will get that the quality tolerance, say quality tolerance of rayon industries, or you can say that in tanning industries, different various industries are there, as you all know. So quality tolerance, that these are different. So that is why the industries may not always take the water from the municipal this water supply system also, or corporation or the Metropolitan Development Authority also. So they may source water from some other parts, right? Groundwater also, and there because of the quality requirement. So that maybe they may be added to the municipal the wastewater also from industries. These are industrial wastewater also. So wastewater, say WW. Here also this. So different industries may discharge their the wastewater also with the permission. Remember, with the permission. Otherwise, it would be unauthorized. So this actually has to be authorized also, so that in consultation with the municipality, and the municipality has given consent, say, to allow their wastewater to enter into the municipal sewage system, so that they can treat. Because the treatability aspects also are there. So suppose the treatment plant is here, STP, as I have already discussed also. So the STP should be able to treat this wastewater coming from different sources also. Accordingly, the industries will be allowed. Some industry may be may not be allowed also, because their wastewater may be not treatable in the municipal sewage treatment plant. So in that case, their own treatment plant, or somehow they will manage that. So this is the STP, and then they are discharging, ultimately they are disposing this one, as I have already explained, in the downstream part also. Downstream in the sense that this is, say, upstream, as I have already here drawn here. This is the downstream. From the upstream of a city or stretch or so, here from the upstream part, the raw water is taken for the water supply scheme, while this downstream, this actually the wastewater after treatment also, this is discharged in the downstream also, so that they cannot contaminate the water supply, raw water here, to be or rather being drawn for the water supply. So that is why this distinction that is to be kept in mind. Okay, and one more point, that is here. So when another point is that you see that we wrote, but we didn't possibly discuss this issue. That is, all this, when water distribution, this system you will design, or water supply system, remember that you sort of first the population which are to be served, so that is there, then institution, commercial needs, and all to be added also, and then an allowance that actually is to be kept for the wastage or leakage. So when this water supply, the pipeline, let me draw here, let me erase this part for the timing, right? So this is the water, this one. Now how it is done, I am just giving very briefly this one, so that you can understand this, right? So this is the, right, like that. So one pipe, piece of pipe, because the pipe, one pipe cannot be so long. Suppose you have to serve this population over a stretch of 5 kilometers, maybe 10 kilometers or so. But one pipeline will not be like. The pipe has got a specific length, which you will get in the manual also, and discussing with the manufacturer also that what is that length also. Normally this 20 feet or so, so that is there. But I am not coming to this issue. Now here, like that. So it is like that. This is suppose the female part, this is the male part, if we say like that, and then this is just connected, jointed, and this joint actually, jointing is made by lead cock or so, different types of nowadays are coming. So we are not discussing here, but this way actually the different the pieces of pipes, and the pipes may be, you know, that may be this cast iron pipe, CI, it may be ductile iron pipe, DI, it may be, you know, the plastic pipe, PVC, right, and it may be, you know, other RCC pipe also may be there. Different sort of pipes are used for water supply system, depending on the diameter, size requirements, etc., etc., etc. So these pipes have got specific lengths also. So this way, this is there, or it may be jointed like this. Suppose this is this, and this here, and there is another pipe say here, and in between to this one, this to this one here. I can't draw this way, right? This is a socket and spigot and socket type, and this is another type which is just riveted, you know, the pipe, this one here ring and this ring, so that actually is, and so many holes are there through which these are riveted, or nut and bolts are used also. So while we will discuss this later, valves, etc. Now this is all about the water supply system, and what we have seen that the water supply system, the Hagen-Williams equation, normally this is used, and here this needs to be understood very clearly, right? So when we are saying that velocity of water, of course, through the pipe under pressure for water supply system, right? So this actually that is V is equal to C, means here the Hagen-Williams coefficient also, right? C, sometimes this is called CR also, right? So C Hagen-Williams, CH, let us say CH Hagen-Williams coefficient. So this is a, right? And then this is R, means the hydraulic radius. So R that you see, that is 0.63. This is the coefficient, Hagen-Williams coefficient, Hagen-Williams coefficient, and these coefficients you will get from the manual or any standard books, or IS codes also. So that may be sourced from this standard literature also, you can get. More or less the textbooks are giving these values. Now this actually, you see, R means the hydraulic radius. Hydraulic radius, which is weighted area can you make it, put this some temperature little down, weighted area, and this is weighted, this is perimeter. Weighted area by weighted perimeter, that is A by P. Okay, and for a circular pipe, let me just explain this one. So that is a circular pipe, right? So that actually when it is running full, as the case in water supply system also under pressure running full. So that time the weighted area, this will be pi, this is the diameter. So this pi d square by 4 is the diameter, right? And this weighted perimeter will be pi into d, twice pi r or pi d, right? So this, if you, pi cancels out, right? Now d and this square we are cancelling. So this are actually for the flow.
One pi will get cancelled. The other pi will be there.
No. Pi d square by 4, right?
Oh, okay.
And this divided by pi d.
Oh, sorry.
So this will be d by 4, right? So this actually, d by 4 will be the hydraulic radius when it is running full, remember, running full. But this is different in sewage flow through sewers also, because it is partially full flow also because of the ventilation. So in sewer, this is the water supply system. I have already explained that this is under pressure, flows under pressure also, and that is why flowing full. And here the in sewer line, right? So the depth of flow is not full. It is always deliberately this one kept, say usually 0.8 or so, depending on the requirements also, and your available the flow also. So that way actually this will be decided. So in the sewer line, this part actually is ventilation, right? Because otherwise the fouling will be there, because this carries wastewater, remember, sewage, which is decomposable. So if you do not have any space for ventilation also, blank space, then this will not be under a full ventilation or required ventilation. As a result, this will be decomposing also, and foul smell. And foul smell means the pipe will be corrosion and the gas will be leaking through manholes also. So these problems are there. I am not detailing this. But here actually the difference, as you see, is striking difference here is that this is full flow, this is partially full, right? And I'll come back later that little more details I'll explain here. So this is this, and another, you see that R and S to the power 0.54, I think that is there, right? Here S means, remember this is very important, H by L, that is equal to S, that is the hydraulic gradient, right? Hydraulic gradient. That means, suppose I am drawing here just for illustration purpose. This is the sewer line flow, right, or water supply, this one. Here, if you puncture this, right, suppose this is punctured. So as it is flowing under pressure also, the water will rise here, say, right? And here, I am erasing this part. Hydraulic radius already defined and explained. And here, if you puncture or piezometer also, piezometric pressure, if you determine or measure, then this will be little lower, because it has distributed some flow also, and head loss will be there because of the friction, right? So friction, when the water is flowing, depending on the pipe, this roughness, right? So that is the Hazen-Williams, this one. This depends on the pipe materials, then age of the pipe. As it will be aging also, then this will be reducing also, so that velocity will reduce through the older pipes also. Newer pipe, this is will be much higher also. So what will be there? This is the hydraulic gradient. This concept is very important. You see that S is equal to H by L. This is not that the pipe is, like that. That is why the bed slope, many, they make a mistake. That this will be the slope of the pipeline. It is not slope of the pipeline. It is just, that this is the slope of the hydraulic gradient. That means here, if you take the piezometric, this pressure, this will be higher than this because of the friction loss. So this is a friction loss, as well as if there is some valves, fittings in between also, and that also will be added, which we are termed as the minor losses also. And depending on this, actually the total amount of this losses that has occurred between these 2 points or stretch or so here. So this actually will be dropping this one. So now suppose this is here and this is here, right? So suppose the del H is in this stretch the head loss, or H say. Now this is, suppose the length is L. So this H by L is actually represented by this one, S, that is the hydraulic gradient. So what is there, I'm not complicating also, what we are doing actually, that we are trying to find out that the discharge we know, so the velocity, the discharge Q, as you know that this is velocity into area, right? So if we multiply by area, that is pi d square by 4 or so further, right? So here that would be the Q. Now Q, you know that how much water is to be supplied, right? And if you, diameter if you choose, then this, for this diameter, the chosen diameter, you will get that d by 4 when that is the R, and S you can determine, right? So what would be the fall or the hydraulic this losses in between these two also, so that you can estimate or that you can determine also. So that actually this is a understanding of different hydraulic formula. All are having same kind of this one, where you will say that in Manning's formula again is that the Manning's coefficient R is remaining same concept wise. Darcy and Weisbach, that FL V square, FL or capital L you can use. This is a friction factor also, right? Or this is a friction factor for Darcy-Weisbach friction factor. This is the length, the velocity, diameter also. Then in that case, that would be, I'm sorry here, this will be Q, this will be again this will be V, FLV square by FLV square by twice GD, no? This would be FLV square by twice G, that is the loss. I'm sorry, you can just correct it. Okay, this is the hydraulic losses, that is H. Okay, now H is the hydraulic losses. The demo 3 also I might have written this one. You can please correct this one. This should be hydraulic loss. And when this L, if you rearrange this one, H by L, which will be equal to S also. So F V square by twice GD, this is equal to S also. So same this S you can get, provided you know, choose D diameter this one, and from the discharge you know the velocity also, dividing by this one, the Q square by S square also. So that will give you the velocity also. So accordingly you can find out that what should be the, the pressure drop. That is the loss of head also. So that is how in water supply system that is designed. When we will do the design, the practice design, which will be as I have already told, that this should be taken for the registered students or participants also. This will be more clear when we will work with design problem also we will work with. So that is there. And the sewerage system, this is how much time, Sohini?
34.
Huh?
34.
34. So let us stop here. So this is the water supply system. Now this is the water supply system. Sewerage system we will discuss later. Okay? Because we want to keep it to a time limit of around 30 minutes or so, each video. So next video, that is demo session 5, we will be discussing the sewage flow through sewer line and in sewerage system also. So that we will be detailing about that how these are not designed this one, but a brief introduction about that. So this is regarding the sewerage system also. We will come back in session number 5. Okay, thank you all for your valued hearing, and Sohini also for arranging this audio visual kind of set also. Thank you.